students, so now we are going to solve a numerical based on Fourier function. So here we have a question that is expand or find Fourier expansion of x plus x square in negative pi to pi, and then we have to deduce two results. Now guys, the thing is how to solve this. So whenever you get the given range from minus pi to pi, always remember that we have to check whether the given function is even or odd, because if it is even function then we don't have to find out bn, because bn becomes 0 straightforward, and if it is odd function then we don't have to find out a naught an, because they both are 0. So guys, your efforts are reduced. Now one more thing over here is, if you see carefully, then there are two functions. One is x and one is x square. So what we'll do is, we'll separate these two functions, because if we are taking it together then it is neither even nor odd. So the question is how to solve this. Should we check for even and odd, or we should not check for even and odd and we should solve it by the general method for finding the Fourier expansion in minus pi to pi? So guys, you may use both the method, but what I'll recommend over here is you use the separation method, because if you use the general method where you're not finding if the given function is even or odd, then you'll get the answer, that is the Fourier series. But let me tell you my friends, you will not get this deduction. Now as we have solved this sum many times, we know that we will not get deduction if we consider this whole function as it is and we solve. So if we want to solve, or if we want to get these deductions from this Fourier series, then the way is we have to separate these two functions. Let's say we'll call this as phi of x and we'll call this as psi of x or g of x, and then we'll prove that this is odd function, this is even function, and then we'll solve this by the method of odd function, we'll solve this by the method of even function, and in the end we will add the result to get the Fourier expansion of f of x. Similarly, to get the deductions, we will use one of the function, that is either phi of x or g of x, to get the deduction. So guys, I'm starting with the second method. So here I'll say let f of x is equal to phi of x plus, you can say, let's say psi of x. Equation number 1. Now let's solve it for phi of x. So here I'll say now phi of x is equal to x, and therefore phi of x is an odd function. So guys, how we got it as odd function? If you put x as minus x, you'll get answer as negative x. So whenever you get phi of minus x equal to minus phi of x, it is called as odd function. So if it is odd, we will find out its Fourier series. So here we have the formula. So the Fourier series for phi of x, which is odd function, is given by x equal to, because left hand side is phi of x. Now a naught and an both are 0, so summation n equal to 1 to infinity bn sine of nx. So here I'll say, since a naught is 0 and an is 0. So guys, it means to find the Fourier series for phi of x, I'll call it as equation number 2. To find out the Fourier series for phi of x, we just have to find out the bn. So let's start. So therefore bn is given by the formula 2 upon pi integration 0 to pi, then f of x sine of nx dx. Now the value of f of x is x, so this will become 2 upon pi integration 0 to pi x sine nx dx. Now guys, here there are two functions which are multiplying each other, so we'll call this u this x as u and this sine nx as v, and I'm gonna use the integration by parts, but the shortcut formula. So I've told you the shortcut formula. So it is 2 by pi as it is, and let's find out the integration. So the first term is u, so x as it is. Second term is v1, that is integration of this, which is minus cos of nx upon n, middle sign minus, then u dash derivative of x, which is 1, then v2, that is integration of this term, so minus sign as it is, integration of cos nx is sin nx upon n, but already there is one more n, so that will become n square. Now I will not move ahead because the derivative of 1 will be 0, so here we'll stop, and limit is from 0 to pi. So let's substitute the limit. So 2 by pi as it is, the upper limit is pi, so here we will get negative pi cos of n pi, that is minus 1 to the power n whole upon n. Next minus minus plus and sin n pi, which is 0, so no need to write. Next middle sign minus, let's put lower limit, that is 0, so 0 into cos is 0 and sin 0 is also 0, so we'll get lower limit as 0. Now guys, we can cancel this pi with pi and we'll get this value as 2 as it is. This minus and minus 1 raised to n will be minus 1 to the power n plus 1 whole upon n. So we have cancelled this pi with pi. So guys, this is the value of Bn. So by substituting this value of Bn here in equation number 2, we can get Fourier series for phi of x. So here I'll say, from equation number 2, by substituting the value of Bn, you will get x equal to summation n equal to 1 to infinity. Now this is what the Bn is, I'll put it here. So that will become 2 times minus 1 raised to n plus 1 upon n into sine of nx. And guys, I'll call this as equation number 3. So we'll see whether to use this equation or not while doing or while finding the deduction. So guys, here I did the solution for first function phi of x. Now let's move to the second function, which is psi of x. So psi of x is x square. So here I'll say, now psi of x is x square. So here you can figure out that psi of x is even function. So here I'll say, therefore psi of x is an even function. So for even function, the Bn is 0. So here I'll say, therefore the Fourier series for psi of x is given by. So guys, by this formula, psi of x is x square, so x square equal to a naught plus summation n equal to 1 to infinity an cos nx, and here I'll say since Bn is 0, and I'll call this as equation number 4. Now guys, we'll find out a naught and an, we'll put it here and we'll get the Fourier series for psi of x. So therefore the formula for a naught is 1 by pi integration 0 to pi f of x dx. F of x is x square dx, which is 1 by pi. Now integration of x square is x cube by 3 from 0 to pi, so that will become pi cube by 3, so 1 upon pi into pi cube by 3. And guys, here we'll get the value of a naught as pi and pi cancel, so pi square by 3. Now let's find out an. So an is given by the formula 2 by pi. So this is the formula, integration from 0 to pi f of x, which is x square, into cos of nx dx. So guys, let's evaluate this integration. So here there are two terms which are multiplying each other. So I'll call first term as u and second as v, because first term is algebraic, and whenever we want to multiply or we want to find out integration of two terms which are multiplying each other, we use the shortcut formula. So in shortcut formula we always take algebraic term as u. So algebraic term is x square, so that is u. So let's apply that formula. So it is 2 upon pi. Here in the bracket we'll get first u, that is x square, then integration of v, that is sine of nx upon n, minus u dash, that is derivative of x square 2x, integration of v1, that is v2, so minus cos nx upon n, that will become n square because already we have one more n, plus derivative of 2x, that is 2, integration of negative cos nx upon n square, so negative sign as it is, sine nx upon n, and this n square will become n cube, from 0 to pi. Now 2 upon pi as it is. Let's put the upper limit. Now upper limit is pi. If I put it here, we'll get sine n pi 0. Here I'll write it down 0. This will become minus minus plus 2 pi, and cos n pi is negative 1 to the power n upon n square, and this is sine n pi again 0. So this is what the value of upper limit. Middle sign negative. If I put lower limit, 0 square 0, 0 into this 0, and sine 0 is 0, so we are getting 0. So it means we just got one term. So here I can cancel pi with pi, and guys here therefore I'll say the value of an is 2 into 2, that is 4 times minus 1 to the power n upon n square. Now we'll put this value of a naught and an in equation number 4 to get the Fourier series for x square. So here I'll say from equation number 4, by substituting values of a naught and an, we will get x square equal to, so first value is a naught, which is pi square by 3, so pi square upon 3. Next here an cos nx, so value of an is this, so out of that 4 is a constant, I'll take it outside, so that will become plus 4 summation n equal to 1 to infinity minus 1 to the power n upon n square into cos of nx, and that will become equation number 5. So guys, we got Fourier expansion for x square and we got Fourier expansion for x. Now these two values we will put in equation number 1, because there we said that our original function f of x is combination of these two functions. So the Fourier series for f of x is a combination of Fourier series of these two functions. So let's put it in equation number 1. So here equation number 5 and equation number 3, that is the Fourier series for this. We'll put these two equations in equation number 1. So here I'll say substituting equation number 3 and 5 in 1. So we will get f of x, that is x plus x square equal to, so first of all I'll substitute equation number 5, which is pi square by 3 plus 4 times summation n equals to 1 to infinity minus 1 to the power n upon n square cos of nx, and then we'll put equation number 3, which is 2 outside, summation n equals to 1 to infinity negative 1 to the power n plus 1 upon n into sine of nx. So guys, this is the Fourier series for given question. So here we are done with first question. Now we have to deduce the result. So if you see the first and second result, then in both the results the terms on the right hand side are the square. So in the first result we want square of each and every term, whereas in the second result we want square of the odd terms, and the even terms are 0. So now guys, to get first result, that is to get only sorry, so guys, to get first result, that is to get all terms and square of all terms, will again go back to the Fourier series which we have derived. So if I will use this series, then according to this I have to make this term as 0, because here we have denominator as n, and we have to make this cos nx term as 1. Then only we will get here 1 square, 2 square and 3 square. Now let's say if I want to make this term as 1, I'll put x as 0. If I put cos, so this x as 0, this cos nx will become 1, and here we will get 0. But guys, if you solve this, you will find that you will not get your answer. So to get your answer, what we'll do is, we will use this series of the equation number 5, that is the series for x square, because in this series here the denominator is n square. So if I put here some value, then we will get the first result. So let's say if I want that result, that is 1 upon 1 square, 1 upon 2 square, 1 upon 3 square and so on, what will substitute? So guys, if you are thinking that let's put x equal to 0, then that's not the solution, because if we put x equal to 0, then here we will get cos 0 1. But when you put n equal to 1, then you will get alternate positive and negative signs due to this minus 1 raised to n. So we have to put such value of x that we should get all terms as positive, and therefore here we will put x as pi, because this will become cos of n pi, and we know that cos of n pi is minus 1 raised to n. So minus 1 raised to n into minus 1 raised to n will become minus 1 raised to 2n, or I can say it is 1 raised to n, which is 1. So we'll get a positive term here and we can get the solution. So here I'll say put x equal to pi in equation number 5. So we will get pi square equal to, on the right hand side we have pi square by 3 plus 4 times summation n equals to 1 to infinity negative 1 raised to n upon n square, and here if we put pi we will get cos of n pi. Now guys, cos of n pi is minus 1 raised to n, so I'll take this term here, so that will become pi square minus pi square by 3 equal to 4 times summation n equal to 1 to infinity. Now this is minus 1 raised to n into minus 1 raised to n, so that will become minus 1 raised to 2n, because if base is same we can add the power upon n square. So if we subtract this 3 pi square minus pi square, that is 2 pi square by 3 equals to 4 times summation n equals to 1 to infinity. Now guys, here if I take 2 inside, minus 1 square is 1, so that will become 1 raised to n, and guys 1 raised to n is 1, so we'll get 1 upon n square. Now if I put different values of n, I'll get 1 upon 1 square, 1 upon 2 square, 1 upon 3 square, that is the required right hand side, and if I take 4 here, that will become 12, and 2 pi square upon 12 is pi square by 6, and guys that is the required result. So here I'll write down, so therefore pi square by 6 equal to 1 upon 1 square, 1 upon 2 square, 1 upon 3 square and so on. So here we got the first result. Now here we got first result, so we'll try to find out the second result. So in the second result we want pi square by 8 on LHS and the square of odd terms on RHS. So again, as I want the square of odd terms only, it is not possible to prove this from the final Fourier series, because if I want odd terms, then first of all I should make this term as 0, and then here I should eliminate the even terms. So instead of this result, we will again use the equation number 5. So here guys, if you observe carefully, then in the equation 5 again we have n square in the denominator. Now the question is which value we should use such that we will just get odd terms. Now let's say if you are thinking about pi, we have already used it. By pi we don't get the answer. Next value, let's say if we put x as 0, then cos 0 is 1. Still we will get all terms. We cannot eliminate the terms. If we put x as, let's say, 2 pi, still we will get all terms. It means in all the cases we are getting all terms. So question is how to get only odd terms, how to eliminate even terms. So guys, so there is a hint. So in the previous result we got all terms. Here you can see. Now as I don't want even terms, what I'll do is I'll try to put the value of x here such that I will get negative even terms. So if I get negative even terms, then I can add that result with this result and we can cancel the even terms. So that's a great idea. So what we'll do is we will call this as equation number 6, and to get negative even terms we will put x as 0, because if cos 0 you will check it is 1, and by putting different values of n we can get negative value of even terms. So let's start with that. So here I'll say put x equal to 0 in equation number 5. So left hand side is 0 square 0, right hand side is pi square by 3 plus 4 times it is summation n equals to 1 to infinity minus 1 to the power n upon n square, and cos 0 is 1. Now if I take this value on the left hand side, that will become negative pi square by 3 equal to 4 times summation n equals to 1 to infinity minus 1 to the power n upon n square. So now if I take 4 here, that will become minus pi square by 3 into 4, that is 12. So I'll keep 4 as it is now and we'll expand this. So here we will get, when n is 1, minus 1 raised to 1, so minus 1 upon 1 square. When n is 2, minus 1 square, that is plus 1 upon 2 square. When n is 3, minus 1 cube is minus 1 upon 3 square. Then plus 1 upon 4 square minus so on. Now guys, you must be surprised that we are getting even terms as positive, but we want even terms as negative. So it's simple. See here we got negative sign on left hand side. So what we can do is we'll multiply both sides with minus sign. So here we will get pi square by 12, and here we will get 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square plus so on. So I'll call this as equation number 7. And now last step, let's add equation 6 and 7 to get the final result. So I'll say adding equation number 6 and 7, we will get pi square by 6 plus pi square by 12 equal to, now 1 upon 1 square plus 1 upon 1 square, I can say that this is 2 times 1 upon 1 square. This negative positive term cancel, again this is 2 times, so I'll get all odd terms 2 times. So 2 upon 5 square and so on. Now guys, let's simplify this. So the LCM is 12, so I'll multiply this with 2. So here also I'll multiply by 2. 2 pi square plus pi square is 3 pi square upon 12, which is equal to 2 times 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on. So guys, here we got all the odd terms. Now 3 ones are 3, 3 fours are 12, and this 2 will come in the denominator, that will become 4 twos are 8. So that is pi square by 8, which is equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and so on. So guys, here we got the required result. So here we have proved both the result by using the concept of even and odd function. So I am sure that you understood this video, and if you want to learn more videos on Fourier series and engineering mathematics, then stay tuned to Ekeeda.com, where you will find all videos at one place. Thank you very much.